Hello everyone, welcome to our channel Everyday E-Learning. In today's video, we are going to practice one problem from the topic combination of events, and we are given the following one. So this is our sample space and we have the three events A, B and C. And we have these 3 points outside of our events A, B and C but inside the sample space. Now let us start with number A. In number A, we are asked to find out the probability of B. So the probability of B will include all these points that we can see inside B. So if we add them up together, we'll get the probability of B. So if we add all this together, we'll end up with 0.46. Now moving on to number B. In number B, we have been asked to find out the probability of B intersection C. Let me rub this one for you first. Alright, now for this one, intersection means the common points between the two events. Common points. Now the common space for the event B and C, this one is B and this one is C, is this zone. So if we add them up together, we get 0.02 plus 0.05 plus 0.11, we get 0.18. Now moving on to number C. In number C, we're asked to find out the probability of A union C. For A union C, we have to take all the elements or the points that are present inside A and C. So we'll have to add this one, this one, this one, this, and this, and this together to get the result. And if we add them up together, we get equal to 0.61. Now moving on to number D. In number D, we are asked to find out the probability of A intersection B intersection C. Now, it indicates that we have to take again the common points that exists between A, B and C. This one is our A. So if I mark the common points between A, B and C, this one is for A and we have the common space B, and for C. So we have only this zone. So if we add 0.02 and 0.05, we end up with 0.07. Now in number E, we're asked to find out the probability of A union B union C. Now for this one, if you remember the concept of union, we have to take all the elements in the three events A, B and C. So if we add them up together, we get the result of this one. We can also find out the result if we subtract the 3 points that are outside the events A, B and C. So we can also do like this: 1 minus 0.04 plus 0.05 plus 0.03 to get the result, or we can add up these 3 elements. So we'll end up with the same result, which is 0.88. Now in number F, we're asked to find out the probability of, okay, this one will be A complement, probability of A complement intersection B. Now for these cases, we'll just cancel out the elements that are present in A and take the remaining elements that are present in B. So we add up 0.08 plus 0.06 plus 0.11 and finally 0.13, and we end up getting 0.38. Now in number G, we're asked to find out the probability of, okay, again this one will be B complement, probability of B complement union C. Now there is a difference between union and intersection, so we'll learn it in this problem. Now whenever we are asked to take the elements that are not in B but in C, so we'll have to be a little bit careful here. So for this one, we can take all the elements that exist in C. So if we mark it here, we'll take all these elements for sure because they exist in C, and we'll cancel the elements that exist in B. These are crossed, and we have to take all the remaining elements. Now you might wonder, why did not we take this one? Why is not this one included? Because this one falls inside the set B, and we are allowed to take the elements that are present in C but not in B. Now in case of these elements, these are present both in B and C, so we cannot ignore this, as this also exists in C. But for this element, it exists solely in B, and we are not involved with the elements that are common between A and B. So we ignore these 4 elements and we take the remaining elements and add them up together to get the result. So we add them up together, we get the same result, or we can subtract from 1 the cancelled elements. 0.08 plus 0.13 plus 0.06 plus 0.01 and end up with 0.72. Alright, moving on to the next one. Now in number H, we are asked to find out the probability of A union B intersection C. So in this one, we can notice that we'll have to take the common elements between B and C. So this one is B and this one is C. The common elements are these, and we have to take all the elements from A. So we have this one, this one, this one, this one, and this one. So we add them up together. We have 0.07 plus 0.05 plus 0.01 plus 0.02 plus 0.08 plus 0.04 plus 0.05 plus 0.11, and we end up with 0.43. Now we are running out of space here a bit. Let me erase some from here. Alright, now in number I, we have to find out the probability of A union B intersection C. Now for this one, we'll have to take the elements, all the elements. Let me clear it up for you first. We'll have to take all the elements from A union B. So we have these elements from A and B, and we have to find out which of the elements that fall inside A union B is common with C. Now we can see that between these we have the common elements in this zone. We have now all these elements fall under the category A union B, and we have the common elements with C as 0.11, this one, these two, and these two. So if we add them up together, we get the result 0.11 plus 0.05 plus 0.02 plus 0.08 plus 0.04, and we end up with 0.30. Now moving on to our last one, number J, we have probability of A. Okay, this will be A complement and this will be complement. A complement union C whole complement. So we have a formula that we can use here. Probability of A complement union C complement is equal to 1 minus probability of A complement union C. So here we can first find out the probability of A complement union C equal to what? So this is similar to that of number G, if you remember. So in this case, what we'll do is we'll take all the elements that are in C, of course. Let me mark. We have to take all these elements that are in C, and we have to take the other elements too, this one, these, and these. Now we'll cancel out this one, and again we'll have to cancel out this one. Now this is because we take all the elements that are not in A but in C. So these are in C and these elements are not in A. So as this one falls in A, we cancel out this one, but these don't fall in A. So we take all these other elements. So if we add them up together, we'll get the probability of this one. Now we can also use the shortcut here. We can just subtract these 3 points to get our desired result. 0.01 plus 0.05 plus 0.07. So we end up with 0.87. Now if we subtract 0.87 from 1, we end up with 0.13, which is our desired result. So that's it for this video. We will practice more problems from this topic in our next video. So please don't forget to subscribe and like our channel and keep updated. Thank you very much. Stay well.